Okay, guys, it is Friday, and I want to talk more to you today about Riemann sums and what they actually are, and it's really not as scary as it seems, even though I know it. People struggle with these. Um, the idea is that I want to estimate the area under a curve by doing rectangles. That's what a Riemann sum is. We've been doing that. I want to find the area under the curve from 0 to 2 using Riemann sums for the given values of n. They can calculate the actual area and compare. All right, so the square root of 4 minus x squared, let's see, that looks something like this. I'm not going to do these by hand. What I'm going to do is show you a nice out. All right, so 4 minus x squared looks something like that. And I'm going to integrate from 0 to 2, so here's 2. And first they want me to do 4 subintervals. So basically my delta x would be b minus a over n. So b is 2 and a is 0. I'm going to use 4 rectangles, so each little subinterval is worth 1/2. So I'm going to draw some lines up. We got 1/2, 1, 1.5, and 2. So those are my subintervals. And I'm going to do them with left or right. And so if I do the left-hand side, you see I get these blue guys. It's going to be, you see that my area is going to be over the actual area of the curve because the rectangles are above it. And if I do the right-hand side, I'm going to do that in red. I'm going to take this. Right, so you see that these guys are underneath it. That's actually 0, isn't it? All right. Anyways, the whole point to you is how can we tell? Pretty much, I just draw a graph, and if all the rectangles are underneath, it's below. If they're over, it's above. And we'll talk more about that today. But what I want to do is show you an app, and we're going to find these areas using 4, 8, 16, 40, and 80 rectangles. We're not going to do this by hand. So there's lots of apps online that will compute Riemann sums for you. There's even calculator programs you can download. Let me find you one. Riemann sums. Oh, let's find an app. My goodness. Well, let's try that again. Applet. There we go. All right, Wolfram's usually pretty good. Desmos is probably good. Let's try Wolfram. All right, so is that gonna make me down? No, let's see if I can get it down here. All right, usually what they'll do is let you enter the function. Yeah, okay. So the function that I'm particularly evaluating today is the square root of 4 minus x squared. So I'm going to type it like that into this 5. And I'm integrating from 0 to 2. And I'm going to use 4 rectangles. And I'm going to start, I guess, with the left-hand sum. And let's see, that should do it. I don't like light gray. Let's do red rectangles. All right, and the plot color, we'll do black. I don't know. All right, replot. All right, so you can see this is a left-hand sum with 4 rectangles, and they gave me an estimate, I hope. Yeah, the estimate was 3.495, and the actual area is 3.141. So you can see that it's over. I'm going to write these numbers down. All right, I forgot what it was. 3.496. So 3.496 actual area 3.142. And we're going to talk about how to find it on a calculator today. All right, so 8 rectangles. I'm just going to change it to 8, 16, 40, and 80. And you see it should converge on a number. So let's do 8. So you see that's a much better estimate, 3.33982. So 3.33982 8. All right, we'll do 16. Uh-oh. What happened there? Not sure. Let's do 16. There it is. All right. Much better. You can write these down in your notes. It's 3.2825. You see that it's getting closer and closer to the actual area, but it's still over. So if I do 40, hello. That's interesting. Let's try 80. It doesn't like that. Maybe too many rectangles for it. No. Let's try 40. There we go. Okay, there's 40, 3.18695. Write that down on your table. And we'll do 80 just to finish this out. So you see that it's getting closer. That looks really nice. Closer and closer. It's really accurate to within 100. It's 3.16495. All these estimates were over the actual area because all the rectangles were over the curve. So 3.16495. So it makes sense that the more rectangles I use, the closer I get to the actual area. So we can see the left-hand sum when it's over. Let's take a look at the right-hand sum. So I'm going to do the same thing I just did, but I'm going to draw the rectangles on the right-hand side. That's not good. There we go. All right, so I'm just going to do 4 rectangles, and we're going to go on the right-hand side. Replot. All right, you can see that those are actually under. There's no rectangle here because the height's 0. So the estimate was 2.496. 2.496. I'm going to put that in my table. I'm not going to do all of these. I'm sure you guys could do these. I'm just going to go through. I just want to look at it. So you see that that's actually under the area, and it'll get closer and closer to the area, but it won't actually get there unless we have an infinite number of rectangles. Okay, so let's do, here's 8. So 2.839. We'll do 16. .998. We'll do 40. 3.08, getting closer. What do we do? 60. I can't remember 60 or 80. We'll do both. Here's 60. And getting pretty close, 3.11. And then if I do 80, 3.11. So we're within a couple hundreds. All right, so it makes sense that the more rectangles I use, the better off I am. Now, your calculator can actually compute an integral. And the way that we would write the area under this curve using an integral is we write it this way using the integral sign. We'd say it's the integral from 0 to 2 of the square root of 4 minus x squared. That would be your f of x. That's your rectangle height and your dx and your width. All right. So we would just enter this into a calculator like that, and your calculator has a command that does that. So if you ever have a calculator on the AP test and you have to do an integral, you don't want to do it by hand. You're going to do it with the calculator. So let me get my calculator up. AB, there it is. Hello, Mr. Calculator. There you are. All right. So what I'm going to do is just show you where that command is. And And if you don't have a calculator, I would recommend keep pausing the video and getting one because you should have one, all right, by now. All right, so what we're going to do is hit Math button. And you see that number 8 was our derivative command. That's how we took a derivative. Below number 9 is fn_int. That stands for integral. So I'm going to pick number 9. And with an 84, this comes up on my screen. And I just pretty much type it in. My lower limit was 0. My upper limit was 2. And I want to integrate square root. Where's square root? Here we go. Square root of 4 minus x squared. All right, and this little d here is my dx. That has to be in there. Type enter, and it's going to compute it, I hope. There it is. Wow, it took a while. 3.14159, so just like what that Wolfram app found. So when you have a calculator, Math 10 is the way to go when you want to integrate something. That's the exact area under the curve. All right. So to get the exact answer, our approximations gets better as we take more subintervals. So that limit there, I wrote it as delta x goes to 0. That's your Riemann sum. It's the integral. It's what we call an antiderivative, or an integral means the same thing. It's the integral from a to b of f of x dx. This is what we call a definite integral. A to b would be numbers. In our case, it was 0 to 2. So I'm finding the area as x goes from 0 to 2. So if I want to write the definite integral to represent the area, the true area of this curve, I don't know the function. Did it tell me what the function was? No, that's a good question. We're going to call it a generic f of x, I guess. So for this particular curve, in fact, I'm going to make something up. Let's call it. Let's call it okay? To write the Riemann sum, it's just simply the limit is the number of rectangles goes to infinity. The sum, I like I know use K today. I use 1 to n or 0 to n minus 1. F of x I, so f of we're going to assume we have even rectangles, so in which case, right is 1 to n. I'm not going to use any specifics here. F of xi is xi squared plus 1, and times delta xi. So that's your Riemann sum. I don't want to get too far into that just yet. Write a definite integral. So the same thing, I'm going to integrate from, and I don't have my limits a to b, so I'm going to make them up. I will say that this is a, and this is b. So we're integrating from a to b f of x dx. So in this case, I don't know what they are. Well, I can call them over 3. So the integral from 1 to 3, and f of x I call x squared plus 1 times dx. So that just represents the area under that curve from 1 to 3. No big deal. All right, let's talk about units though, because units, since the elements being added up are products of the form f of x times the difference in x. So in other words, the width times the length of the rectangle. The units are the product of the length and the width. So if f of t is the velocity measured in meters per second and time is measured in seconds, so if you think about it, you've got meters per second and seconds. So the width of the rectangle is seconds and the height is meters per second. So the units are meters per second times seconds. And the seconds cancel and you get meters. So pretty much it's the units of f of x times the units of dx. That's what we're doing. We're multiplying these two units together. Okay? And the integral represents a net change. Okay, with how many meters have been traveled from that amount of seconds. All right. The table gives a value of a function obtained from an experiment. Use them to estimate the interval from 0 to 6. Since we've done this for several days, I'm going to go ahead and let you guys do this problem. How would my answer change if I use 3 equal subintervals? Well, if I use 3, I'm going to, instead of going from 0 to 2, I'm going to go from 0 to 2, 2 to 4, and 4 to 6, right? That's what I need to do there. I would have trouble doing the midpoints any other way. So let me tell you this: do the midpoint with 3, because then you have your midpoint halfway between 0 and 2 is 1. So you're going to use that 1. So anyway, since we've already done that, I'm going to let that go. That's that. Right? So today, pretty much just a review day. Not much to it other than I want you to know how to integrate something on a calculator and to understand that as you sum those rectangles, it brings closer and closer to the area under the curve. And the units of an interval are the units of f times the units of dx here. And it represents a